There is yes, please. On. Online students, someone respond. Am I audible or not?
Audible,
sir.
sir.
This is not on by. Have you seen that exceptions? Huh? Oh, few exceptions are there. Aqueous NaCl, dilute, concentrated by using mercury as. Okay. So yes. This one, right? Electrolysis of yes, sir. Yes, sir. Visible, huh? No. How come this? We have to take class like this, huh? Okay. No girls, na inside class. Okay. Shall I trust you? Now, see this. In previous class, what we have seen is we are discussing about electrolysis process. What is electrolysis? What is preferential discharge of ions order? Everything we have done, right? So, what is happening?
Turn off the fan.
Yes, sir. Now see this. Please. While we are discussing about preferential discharge of ions, in anions we have seen certain order, right? We discussed something about water and Cl minus, what it is. If concentration of Cl minus crosses certain over voltage, if concentration of Cl minus crosses certain concentration, instead of water, Cl minus will undergo oxidation preferentially. Correct? Correct, sir? Now, in which one electrolysis we have done? Electrolysis of NaCl using platinum electrodes. If it is not a dilute, if it is a dilute, both cases we have seen. Same if mercury is taken as cathode, then what happens? Instead of H plus, Na plus ions undergo reduction spontaneously. Correct or not? Right? Reason mercury dissolves Na plus ions. Electrolysis of 1:1 molar mixture of Na2SO4 and H2SO4. Right? That is nothing but preparation of hydrogen peroxide. Right? Correct? Now we are discussing about electrolysis of metal ion using same metal as anode. Example we have taken electrolysis of copper sulfate using copper as anode. Now, what is electrolyte? Need to make the pen active. Just a moment. Let me activate the pen. So, what will be the electrolyte, sir? If I use electrolysis of copper sulfate aqueous, what will be electrolyte? Say something. CuSO4 aqueous is electrolyte. What are the cations and anions available? Cu plus 2, H plus. These are the cations. What are the anions available? SO4 2 minus and H2. Generally, which is preferred to undergo reduction among these two? In general, copper plus 2 H plus, which is preferably reduced. Copper plus 2 or a plus 0.34. H plus is 0. Correct? So its reduction potential is positive. So among copper and H plus ions, copper will be reduced preferentially. Among these two, among SO4 2 minus and water, which is preferred? Water. If it is HSO4 minus, if it is HSO4 minus, then HSO4 minus is preferred to form H2S2O8, Marshall's acid, which undergo hydrolysis to form Carros acid, H2S2O5, H2SO5, then which will convert into hydrogen peroxide. Correct? Huh? Respond. Now, if it is SO4 2 minus and water, which is preferred? Water is preferred. Already we discussed this idea, right? Now I am taking cathode. So I am using copper as cathode, sir. I am taking copper cathode. Now, what happens at copper cathode? Copper plus 2 gain electrons and copper gets deposited on the surface of it. And I am taking copper anode. What I told you here. If the same metal is used as anode, instead of any anion, anode undergoes oxidation. Are you able to understand? In metal ion solution, if it is copper plus 2, I am using copper rod as anode. Then copper metal will undergo oxidation. If it is Ag plus ions, Ag as anode, right? Now silver will undergo oxidation. Means when a particular metal is used as anode in its metal ion solution, anode will undergo oxidation. Is it clear? Not anion or water. Instead of them, anode will undergo oxidation. See this. That's why we are using electrolysis refining of crude metal to pure metal, right? So at anode, copper converts to copper plus 2 plus 2 electrons. I am writing that note, sir. Very, very important point. If M is used as anode, if M is used as anode during electrolysis of M plus N aqueous, then anode undergoes oxidation. Yes, sir. Yes, sir. Please. Right? Based upon this idea, we are going to purify metals. How I am going to purify metal means I am taking pure metal as cathode, impure metal as anode. I am taking pure metal as cathode, impure metal as anode. Right? Now from impure metal, what happened? Copper is dissolving. From electrolyte, pure copper is getting deposited. So whatever impurities present in this anode, they all will be collected at the bottom. So we call that as anodic mud. Are you able to understand? I'm repeating again. This is electrolyte having copper plus 2 ions. And I am taking one metal rod. This is copper rod. This is copper rod, which is negatively charged. This is also copper rod, but it is impure copper rod. This is connected to positive terminal. So we call it as anode. This as cathode. Now what happens means from solution, copper plus 2 will get deposited on the surface of this rod. What happens to size of this rod? Increases. Now from anode, copper goes into the solution as copper plus 2. What happens to size of anode? From impure copper, if copper alone is going out, what is left here? Impurities are left. If impurities are insoluble, then what happens? All those impurities will be collected at the bottom. So we call it as anodic mud. If impurities are soluble, they will dissolve. Is it clear? This is how we are going to purify metals. Right? We call that as refining process. Clear? Understood or not? Now, what do you mean by electrolytic refining? Tell me, electrolytic refining method means during electrolytic refining, impure metals should be taken as anode, pure metal strip, small piece of pure metal should be taken as cathode, and electrolysis is done by using same metals solution as electrolyte. Right? Now, by using the same technique, we can do coating also, metal coating. For example, I have taken silver rod, which is connected to negative terminal, which is taken as cathode. Right? I am taking gold rod connected to positive terminal, and it is immersed in Au plus 3 aqueous. Now tell me what happens during electrolysis. This is anode. What happened? Au plus 3 will get deposit on the surface of silver rod, and from this rod, Au plus 3 will dissolve. So what you are getting now? Gold coating on the surface of silver. Correct or not? So we call it as electrolytic coating method. Right? So to coat some metals with other metals, we use this technique. Right? Not only for purifying metals, in order to coat other metals on the surface of some metals, we are going to use this method. Clear? Understood? So electrolytic refining of crude metals to pure metals, and also for metal coating. Understood? Any questions in it? So silver plate coated with gold plate. By using this technique, we are following it. Right? Say something. Online student, someone respond. Understood or not?
Yes, sir.
Understood,
Online. Right. One more idea.
Yes, sir.
This is a till last year, almost every year they are giving one question based upon this idea. This is from deleted portion, right? So for JEE Advanced, it is very, very important bit, right? So directly I will show you this from NCERT textbook, right? Metallurgy chapter. See this one? Electrolytic refining. Just now we discussed, na? Electrolytic refining. What we will do in electrolytic refining? Just now we discussed. Pure metal should be taken as cathode. Impure metal should be taken as anode. Read it. In this method, impure metal is made to act as anode. A strip of same metal in pure form is used as cathode. They are put in a suitable electrolytic bath containing soluble salts of same metal. The more basic metal remains in the solution, and less basic metals are collected at the bottom as anodic mud. Right? This process also explained by Dipsity and Jit. They are saying something. Copper is refined using an electrolytic method. Anodes of impure copper and pure copper strips are taken as cathode. Electrolyte is acidified solution of copper sulfate, and the net resultant of the electrolysis is a transfer of copper in pure form from anode to cathode. Impurities from blister copper, that impure copper is called blister copper, deposit as anodic mud, which contains antimony, selenium, tellurium, silver, gold, and platinum. A recovery of these metals may meet the cost of refining. Zinc may also be purified by using this way. Understood this idea? Right? Any questions in this? So now what I will do is, this topic I have already completed to weekday student. That's why directly I am showing it. Right? I am not going to write the same thing again. Huh? See this? Same I have written here. I will copy paste this one there. Right? Less basic metal impurities deposit as anodic mud. Antimony, selenium, tellurium, silver, gold, platinum, etc. More basic metals goes into electrolytic solution. During electrolysis of copper sulfate using inert electrode. This is electrolysis of copper sulfate using copper as anode. Any questions in this? Shall I go to next topic then? Right? Same thing I will copy paste here and stop writing. Understood now the idea? Right. Online. Shall I go to next topic?
Yes, sir.
Yes, sir.
Yes, sir.
Now, sir, two important definitions or two important laws present in electrolytic cell. If you complete that, electrolytic cell part is over. Faraday's first law of electrolysis and Faraday's second law of electrolysis, right? Very, very important. So first one, let me start with Faraday's first law of electrolysis. Don't worry, I will upload the notes, right? or I need to switch on light. Okay, na? Now serious. So let me explain that by taking one example. We discussed about electrolysis of aluminum. We discussed it or not? Hardy group, boron family. Okay. In boron family, electrolysis of aluminum, extraction of aluminum, we discussed it. Bayer's method, Serpek's method, Hall's method, Hall-Herold's process, Hoop's method, red bauxite, white bauxite. What? We discussed it, na? Do you remember or not? No. Okay. I will explain it again briefly and I will come back. Right? Let me explain it briefly. See, bauxite is the major ore of aluminum, right? So what we do is here, first we need to purify the ore. To purify the ore, we have different methods. One is Bayer's method, Serpek's method, Hall's method. These are the three methods. Bayer's method is suitable for purifying red bauxite. Serpek method is suitable for purifying white bauxite. Red bauxite means Fe2O3, ferric oxide is the major impurity in it, right? So that's why I'm writing Fe2O3 plus Al2O3. Al2O3 is ore of aluminum, Fe2O3, ferric oxide is the major impurity present in it. That's why it is called red bauxite. If silicon dioxide is major impurity, then it is called white bauxite. If both are present as impurity, then I prefer Hall's process. Clear? So what we do here is, first I will crush that into powder, right? So that powdered form of ore, in all the three cases, I will take the powdered form of ore. For that, I am adding sodium hydroxide, right? Or first I will do roasting. Roasting means heating in presence of air. When you heat in presence of air, if any lower metal oxides are present, they will be oxidized to higher metal oxide. Means along with ferric oxide, some amount of ferrous oxide also may be present. That ferrous oxide also completely converts into ferric oxide. So during roasting, it completely converts into ferric oxide and Al2O3. If any ferrous oxide is present, that also converts into ferric oxide.
Thank you.
Yes. Right? Now, this one now leached with sodium hydroxide. What do you mean by leaching? What leach do? Sucks the blood out. Same way, sodium hydroxide is the chemical which will make Al2O3 to dissolve. So what is left over? Fe2O3 remains insoluble. So this is obtained as precipitate and Al2O3 is soluble in NaOH to form sodium meta-aluminate. Right? Now by filtering, if I filter, what happens? Iron oxide is gone. This will react with water, undergo hydrolysis to form aluminum hydroxide. Now I will do seeding process. During seeding process, what happened? During seeding process. What do you mean by seeding? Or for example, if I slowly cool water, even if the temperature is less than 0, sometimes water will not convert into ice. In that cases, if you create any disturbance, or if I keep one dust particle, what happens? Immediately crystallization starts now. We call that as seeding, right? So we will initiate the crystallization process. Aluminum hydroxide is actually not soluble in water, but it has to precipitate first. To precipitate it, I will add a drop of freshly prepared aluminum hydroxide. The moment I add freshly prepared aluminum hydroxide, this aluminum hydroxide starts depositing. We call that technique as seeding technique, right? So during seeding, this aluminum hydroxide will precipitate. Now what we will do is this precipitate on strong heating converts into Al2O3. Means what I have done indirectly. I have removed all the impurity from ore or not, and I got pure Al2O3. Clear? So what we call this technique as removing impurities from ore is called drussing. What we call it as drussing process, right? So we are now done with the drussing process of ore. Same way, if silicon dioxide is present as impurity, then we will heat this total solution. I have done something. What is it? SiO2. Huh? Okay. Here, what I do, I will heat this with molten sodium carbonate. I will add molten Na2CO3 to this mixture, right? Then silicon dioxide converts into silicon dioxide remains insoluble. Al2O3 converts into this later converts into ALOH thrice. This on heating converts into Al2O3. Silicon dioxide is removed. Now, in this method, we will heat it with carbon and nitrogen. Clear up? I am heating that with carbon and nitrogen. This can be used here also. We can use this technique here also, right? I will do one thing. What happens if I use the technique here? If I heat it with carbon and nitrogen, aluminum oxide react with nitrogen to form aluminum nitride. Silicon dioxide reacts to carbon to form silicon plus carbon converts into carbon monoxide or carbon dioxide. But be cautious, sufficient amount of carbon should be added, not excess. If it is excess, silicon will combine with carbon to form silicon carbide. What we got as? Carborundum, highly abrasive material, right? So that's why measured quantity of carbon is added so that silicon will not convert into silicon carbide. Now, these two are vapors, those vapors will escape out. Now, this aluminum nitrate on hydrolysis gives aluminum hydroxide. This on strong heating gives Al2. So, whatever may be the method, Bayer's method, Surfex method, or Hall's method, what we are going to do? We are converting that into pure Al2O3. Now, pure Al2O3 have melting point close to 2000 degrees centigrade. Melting point of Al2O3 is very high. Boiling point of aluminum metal is very low, maybe approximately 1300 degrees centigrade. Means what we are going to do? Before melting at the melting point of Al2O3, if you are getting metal converts into vapor and metal is escaped. Then our major aim of producing aluminum metal is gone. So that's why I should not heat this up to this temperature. So to decrease melting point and to increase electrical conductance, I am going to add fluoride and cryolite, Na3AlF6. Right? So what is their role? To decrease melting point and to increase electrical conductance. Right? Now, after adding them, this will now heat it at approximately 800 to 900 degrees centigrade. At that temperature, now it will melt. Now I am doing electrolysis. What are the ions available? Ca plus 2, Na plus, Al plus 3, Ef minus. Correct? Huh? Among all these cations, which is preferably reduced? which is preferentially reduced? Sodium, calcium, and aluminum. See the table. Sodium, calcium, aluminum, which is reduced preferentially. Huh? See these values, which is preferentially reduced. Aluminum, which is above in series, that will be reduced preferentially, na? Say something. Among H plus and copper, which is reduced preferentially? Copper, because copper is above H plus, right? So in electrochemical series, whichever metal is above in the series or whichever having positive value of reduction potential, that is reduced preferentially, right? Or which is having higher value of reduction potential, that will be reduced preferentially. Clear? So among aluminum, sodium, calcium, which is reduced preferentially means aluminum. Understood? So at cathode, what happens now? What happens now at cathode? Al plus 3 gain electrons to form aluminum metal. Now, what happens at anode? F minus ions are available. This goes towards anode to produce fluorine gas. This fluorine gas now react with Al2O3 to form aluminum fluoride plus oxygen gas. This oxygen gas react with anode. What is this anode? Graphite anode, right? This will react with carbon to form carbon monoxide plus carbon dioxide. That's why what we discussed during extraction of aluminum, anodes rods must be replaced timely. Reason? Obtained oxygen started reacting with anode. So anode is lost. That's why we need to replace those rods continuously. Now you got AlF3. This AlF3 again converts into Al plus 3 and F minus. This Al plus 3 goes toward cathode to deposit aluminum. This F minus produces fluorine. That fluorine keep on reacting with Al2O3. Means indirectly what is happening? Indirectly we are using Al2O3 only. Na? Clear? So this is during extraction of aluminum. Correct? Respond. Now I am coming back. So during extraction of aluminum, what we are doing? Al2O3 is mixed with fluoride and cryolite. Correct? What is the role of these two? What is the role of these two? To decrease melting point and to increase electrical conductance. Simply can I write kappa? To increase kappa. Okay, better I will write to increase electrical conductance. Now what happens at cathode? What happens at cathode? Say something. Al plus 3 gain electrons to form aluminum sponsor. And what happens at anode? What happens at anode? Graphite rods are taken as anode. What happened? F minus gives rise to form F2 plus 2 electrons. This F2 now react with Al2O3 to form 2 moles of AlF3 plus 2s are 6, so 3 O2 plus 3 by 2 O2. Correct? Correct or not? Now, what this O2 will do? This will react with anode. Response, sir. That oxygen liberated will react with anode to produce CO and CO2. That's why anode rods are replaced continuously, right? Now at cathode, this is the reaction. Now I am talking about cathodic reaction only. I am not bothered about anodic reaction. I am talking about cathodic reaction. Observe here carefully. Observe this reaction. How many grams you will get here? To have 1 mole of aluminum, I need to use 3 moles of electrons or not? Correct? So to get 27 grams of aluminum, how much charge I need to pass? 3 Faraday. Response, sir. Correct or not? And if I use 3 moles of electrons, then I will get 1 mole of aluminum. Yes or no? 1 mole of aluminum means 27 grams. 3 moles of electrons means 3 Faraday. If I pass Q coulombs of charge, then how much I will get? I am assuming W grams. I am assuming W grams. Find W, what you will write. Therefore, W upon 27 is equal to W upon 27 equal to Q upon 3F. Response, sir. Correct or not? W upon 20 or just directly divide both. If I divide them both, what you will get? 3F upon Q equal to 27 upon W. Therefore, what is W equal to? 27 upon 3F into Q. Correct? Correct or not? Means W is equal to, instead of 27, can I write atomic weight? Instead of 3, can I write n factor? Can I write it or not? Into Faraday into Q. Any questions about this formula? Do you have any questions about this formula? That formula is nothing but Faraday's first law of electrolysis. Right? Now look at this formula. From this formula, can I write W is directly proportional to Q or not? From this formula, can I write W is directly proportional to Q or not? Yes? Weight of metal deposited or gas liberated is directly proportional to charge Q. That is, W is proportional to Q. Can I write this or not? Can I write that formula or not? W is directly proportional to Q. Respond online. Can I write that?
Yes, sir.
So I am writing W is proportional to Q. So to remove that proportionality, I am writing W is equal to, that implies W equal to proportionality constant Z into Q. This Z is called electrochemical equivalence. Electrochemical equivalence. Now tell me, what is Z value? Already we know. What is Z value? Atomic weight upon n factor into F. Instead of writing atomic weight by n factor, can I write equivalent weight? Atomic weight by n factor is nothing but called as. So directly can I write Z equal to equivalent weight by Faraday, right? So Z equal to equivalent weight upon Faraday. Instead of Faraday, can I write 96,500 coulomb? Instead of Faraday, can I write 96,500 coulomb or not? Any questions in it? Now combining everything, we can write, therefore W is equal to atomic weight of any element or metal upon n factor into Faraday into, instead of Q, right, can I write I into T? Charge can be written as I into T or not? Can I write Q equal to I into T or not? So what are the units of I? Ampere. Time must be taken in seconds. So this formula is called as Faraday's first law of electrolysis. Any questions, sir? Do you have any questions in it? Shall I go to next one? Right? So let me write that in different forms. Note under that first point, point 1. Note point 1. So I am writing weight equal to atomic weight upon m factor into F into I into T. Correct? Instead of metal, if I am any gas is liberated at cathode or anode. So instead of weight, I have to write volume. Then what will be the formula? Volume of gas liberated. Volume of gas liberated equal to what I will write. If it is metal, weight equal to equivalent weight or atomic weight by m factor. If it is volume, what I will write? Molecular volume by n factor. Or if it is weight, weight of that atom. If it is molecule, weight of that molecule. If it is volume, what I'm writing? Volume of that gas divided by n factor. Right? So what is equivalent volume? Or what is molecular volume? 22.4 liters. The volume of any gas, 1 mole of any gas will be 22.4 liters now. So directly I'm writing molar volume of gas upon n factor into Faraday into I into T. Right? Molar volume of any gas is always 22.4 liters. That already we know. Now, point number 2. Efficiency of a cell. Efficiency of a cell. How to find efficiency of a cell? Right? If I pass 3 Faraday, how many grams are getting deposited here? On passing 3 Faraday, how many grams is getting deposited? 27. Instead of 27, if only 9 grams got deposited, what is its efficiency? 9 by 27 into 100. And by passing 3 Faraday, if 27 grams got deposited, it is 100% efficient. Instead of 27, if only 9 grams got deposited here, what I will write? 9 upon 27 into 100 is the efficiency, na? So what I will write? Weight deposited upon weight to be deposited into 100. So efficiency of a cycle or efficiency of the cell equal to efficiency of cell equal to weight deposited upon weight to be deposited into 100. Weight deposited upon weight to be deposited into 100. Right? Instead of weight deposited or weight to be deposited, I call this as experimental value and this as theoretical value or calculated value. Right? Experimentally, how much I got? Theoretically, how much I should get? Right? Instead of theoretical value, can I substitute this formula directly? This is theoretical data only, na? So from this, instead of this weight, directly can I substitute that formula? Respond. Then what I will get? What I will get there? Right. So I am writing this formula as weight to be deposited equal to efficiency of cycle into now will you listen? I told you many times, if someone speaks in class, I will feel more irritated. If I feel irritated, I will complete the syllabus. I will not explain anything. I am getting paid only to complete the syllabus. I will complete. And you will not even know which part I have skipped. Refer any book, you will find everything present in the book. I will do it. Right? I am completely occupied from morning to evening. In spite of that, I am taking some time to take classes for you. If I feel irritated now, I will give your class to some. That's all. Only for deserved students, I will take class. Very seriously, I am saying. I am happy with that students, limited students, 25 or 30 students I will find. I will take classes only for the 25, 30 students. I will make sure that they will listen properly. Remaining all students, I will say thank you very much, Ram Ram. In my class, you should be off pin drop silent and you need to listen. Right? What is the formula for it? I am taking experimental weight as W is equal to efficiency eta into calculated weight. What will be calculated weight? What is calculated weight? This is nothing but calculated weight only now. So what I will write it as? Atomic weight upon n factor into Faraday into I into T. Response, sir. Any questions in it? Now, point number 3. Instead of writing weight, can I write density into volume? Instead of weight, can I write a density into volume? Instead of volume, can I write area into thickness? Volume of metal deposited as area of the metal into thickness of metal. So, I am writing that as A into B, area, C as thickness, into D as density. Can I write it? A into C, length into width, area of metal surface or area of electrode. Area of electrode into thickness of metal deposited. Then what you get? Volume of metal deposited into density. Then what you got? Weight of metal deposited, right? C is thickness, D is density, A into B is area of metal surface or area of cathode. Now this is equal to E upon F into I into T. Can I write it? What is E? Equivalent weight upon Faraday. Can I write this also? A, B, C, D equal to E by F into I into T. Respond. Right? So this is about Faraday's first law of electrolysis. Now I'm going to Faraday's second law of electrolysis. Do you have any questions in this? Do you have any questions in this? No, no? Easy one. So Faraday's first law, W is proportional to Q over. Right? Now Faraday's second law of electrolysis, sir. Faraday's second law of electrolysis.
Sir.
Yes, sir.
Sir, in the third equation, eta is missing now. Sir.
If efficiency is not 100%, I have to write eta also. If I have not written efficiency, means it is 100% efficient. Clear?
Okay, sir.
Now, Faraday's second law, sir. If two or more electrolytic cells are connected in series, two or more electrolytic cells are connected in series. What happens, sir, if they are connected in series? First cell, second cell, third cell. If all are connected in series, charge, electrical charge passed through first cell will be always equal to second cell and third cell also, because to close the circuit, current has to pass through all the three cells, no? Right? So if two or more electrolytic cells are connected in series, then Q passed through cell A equal to Q passed through cell B is equal to Q passed through cell C. Correct? So according to Faraday's first law, what is Q? Q can be written as W upon Z. Right? So I am writing this as, that is, instead of QA, I am writing WA upon ZA equal to WB upon ZB equal to WC upon ZC. What is it? Electrochemical equivalence can be written as equivalent weight upon Faraday. Now that Faraday goes to numerator. So in all the three cases, you got Faraday in numerator. So Faraday gets cancelled. So what is left? Weight of A upon equivalent weight of A equal to weight of B upon equivalent weight of B is equal to weight of C upon equivalent weight of C. Yes or no? Is it acceptable or not? Means if two or more electrolytic cells are in series, what happens? Then weight to equivalent weight ratios of elements in all the three cells will be equal. Right? If two or more electrolytic cells are connected in series, then weight to equivalent weight ratio or I will write weight of metal deposited to equivalent weight of metal in all cells will be same. Will you understand the statement, sir? If two or more electrolytic cells are connected in series, then ratio of weight of metal deposited to equivalent weight of metal in all cells will be same. Correct? So this is called Faraday's second law of electrolysis. Have you seen this formula anywhere? Have you seen this formula somewhere? Last year, at the same time, we are discussing mole concept chapter. While we are discussing mole concept chapter, we discussed about equivalent weight. When we discussed equivalent weight, same formula we discussed. And there I told you the same thing we will discuss in electrochemistry chapter on the name Faraday's second law. Do you remember or not? For everything, I need to go back and I need to show. Last year summer classes, if you remember. Some basic concepts of chemistry. See, same example. While we are discussing normality, there we discuss this point. Equivalent weight equal to atomic weight or molecular weight by n factor. Equivalent weight AB equal to equivalent weight of A plus equivalent weight of B. Weight of A by equivalent weight of A equal to weight of B by equivalent weight of B. We also call this as Faraday's second law of electrolysis. Clear? I will close this. So we are done with Faraday's first law of electrolysis and Faraday's second law of electrolysis. Right? Now we can go for next part, sir. Electrochemical cell. In this chapter, how many parts we are going to discuss? Conductance and conductivity, electrolytic cell, electrochemical cell, batteries, corrosion. So we are done with the 2 parts. Now I am going to third part. What is it? Electrochemical cell. Next sliding, sir. Electrochemical cell. Actually, this is already over. We already discussed it. Just I need to show that under this side heading. That's all. Already we discussed it. What is difference between the electrolytic cell and electrochemical cell? Electrochemical cell means chemical energy got converted into electrical energy. Electrochemical cell, here chemical energy gets converted to electrical energy. Whereas electrolytic cell, in electrolytic cell, electrical energy converted to chemical energy. Electrical energy got converted to chemical energy, right? Now, what is the charge of cathode here in electrolytic cell? Cathode is negative, anode positive. At cathode, reduction occurs. At anode, oxidation occurs. Whereas in electrochemical cell, cathode is positively charged. Anode is negatively charged. But at cathode, reduction occurs. At anode, oxidation occurs. Do you remember we discussed this point already? Any questions in this point? Do you have any questions, sir? No, no? And in electrochemical cell or electrolytic cell, whatever may be the cell, always electrons flow from anode to cathode via external circuit. Now, in electrolytic cell, which decides cathode is negative? External source decides charge of electrodes. But here, chemical energy decides charge of electrodes. Is it clear? So in electrolytic cell, external source is responsible for charge of electrodes. In electrochemical cell, chemical potential is responsible for charge of electrode. Chemical potential is responsible for charge of electrodes. There, external source is responsible for charge of electrodes. So let me show this. Example for electrochemical cell is galvanic cell or voltaic cell. See this one. This is example for electrochemical cell. As I have connected voltmeter here, I call it as voltaic cell. If I connect galvanometer to measure electrical current, here I will measure voltage. If I am connecting galvanometer to measure current, I call it as galvanometer. Now, zinc rod is undergoing oxidation. And what is the charge of anode? Negative. As zinc is leaving electrons on the surface of this rod and goes into the solution as Zn+2. That's why zinc is getting negative charge. Zinc is leaving electrons and going into the solution as Zn+2. As zinc is leaving electrons on the surface of rod, you are getting negative charge. So, chemical reaction is responsible for the charge. Pull electrons out of the rod and gets deposited as copper. Rod is getting positive. So chemical reactions are responsible for charge in electrochemical cell. So this is electrochemical. What is the direction of flow of electrons? Again, anode to cathode. Current will be in opposite direction, right? So which is responsible for charge? Chemical energy is responsible for charge. Is it clear? Any questions? If it is electrolytic cell, this is electrolytic cell. Which is responsible for charge? Battery. External source is responsible for charge. Clear? Any questions? So one small diagram we need to discuss, a very, very important point. So let me take it as a note. I think in NCRT, that image is present. Let me take that. Electrochemistry. See this? Oh, see, I opened class notes. Huh? I don't want this. NCRT. Now, six. Electrochemical cell connected with external source. That we need to see. All these things we have discussed. This is also done. What is this? This is hydrogen electrode. This one. This diagram we need to see first. We can take any one of them, right? Or I will take them separately. See this, sir. If this part is not there, only up to here this cell is there, then what is this? Electrochemical cell. Now what we have done, that electrochemical cell is connected with some other external circuit. It is connected with another external circuit, right? Already we know that electrons always try to flow through less resistant path. Wherever resistance is less, they always try to flow in that direction, right? Compared to this voltmeter, if resistance in this circuit is low, what happens? Instead of making electrons to flow in this direction, electrons now choose this path, right? They will flow like this. Correct? Respond. Respond, sir. Here I can change the resistance by moving this jockey. I can change the resistance. This is called variable resistor, right? Any questions? No. What is the charge of this rod? Negative, right? So I am writing the same diagram in some simple way. Same diagram I am writing in a similar way, but in a simple form, right? So what I do is, I am taking the image only up to this extent. For this, I am connecting external circuit, negative terminal, positive terminal. Response, sir. Instead of making that complicated, just I have directly connected. This is E external. What is the charge on this rod? What is charge on this rod? Negative. What is the charge here? Negative. Right? Now what happened? This battery tries to send electrons in this direction. Battery is providing voltage. So this will be the direction of flow of electrons, correct? Now what this zinc rod tries to do? Zinc rod tries to convert into Zn+2 by leaving electrons here, correct? Now zinc rod is trying to push electrons in this direction or not? Respond. Zinc rod also pushing electrons in this direction, external source also pushing in this direction. If this external source is not there, we know that EMF of this cell is 1.1 volts. Already we have seen it or not? Zinc rod is plus 0.76 volts. Copper reduction potential plus 0.34 volts. Net EMF of the cell is 1.1 volts. So zinc rod, from zinc rod to copper rod, electrons are moving with a force of 1.1 volts. Right? If this E external is less than 1.1 volts, then what among these two, which will dominate? If this E external is less than, it is not pushing electrons more than 1.1, if it is pushing electrons in less than 1.1 volts, or if this is less than 1.1 volt, this is pushing electrons in with 1.1 volts. Now which will dominate? Now what is the net direction of flow of electrons? Correct? Any questions? Instead of that, if E external is greater than 1.1 volt, now this will be the net direction of flow of electrons. Zinc rod is pushing electrons with 1.1 volt. If E external is greater than 1.1 volts, what happens? If a battery is having voltage greater than 1.1 volts, what is the net direction of flow of electrons? Correct? This will be the net direction of flow of electrons or not? Any questions? Right? Now I am coming back. Understood or not? If E external exactly equal to 1.1 volts, no net direction of flow of electrons. Correct? Yes or no? Now I am taking those images as it is. Are you able to understand these three images now? Right? Is it clear? Now I am writing here, sir. If E external is less than E of cell. Instead of writing 1.1 volts, I am writing it as E of cell. If it is zinc and copper, E of cell is 1.1 volt. If E external is less than E of cell, then what is the direction of flow of electrons from anode to cathode, or from zinc rod to copper rod? Correct? If electrons are flowing from zinc rod to copper rod, it is behaving like electrochemical cell only. It is just behaving like this only. Correct? So then it behaves as electrochemical cell, and which is responsible for charge over zinc rod. Chemical reaction is responsible for charge over the zinc rod. Correct? Any questions? Now coming to this, if E external is equal to E of cell, then what is the net direction of flow of electrons? What is the net direction of flow of electrons? No net flow, right? No net flow of electrons. Right? When there is no net flow of electrons, now tell me what is the charge over zinc rod? What is the charge over copper rod? No charge. That's why they have not written any charge. Clear? Are you able to understand? There is no net direction of flow of electrons. Now, if E external is greater than E of cell, then what is the net direction of flow of electrons? If E external is greater than E of cell, now do electrons flow from zinc rod to copper rod, or now electrons flow from copper rod to zinc rod? Electrons is flowing from copper to zinc. Is it clear? Response, sir. Any questions in it? Now, copper rod is connected to negative terminal. Here, zinc rod is connected to negative terminal. Correct? Say something. Now tell me, if electrons are flowing from copper rod to zinc rod, means do chemical energy is responsible for the charge, or external circuit is responsible for the charge? Means then this cell behaves as electrolytic cell. Is it clear? Then it behaves as electrolytic cell. Electrons flow from copper to zinc. Here no net flow of electrons. Here electrons flow from zinc to copper. Is it clear? Here zinc behaves as anode. There copper behaves as anode. Right? This is how our UPS will work. Our at home batteries all will be there, na? Right? If external power source is there, the external power source is greater than voltage of the battery, then what happens? Cell reactions get reversed. When power is gone, chemical reaction is responsible for flow of electrons. When external source is present, external source brings a chemical reaction. When external source is off, chemical reactions brings power. Is it clear? If both are equal, no net flow. When there is no net flow, means when voltage goes down or when low voltage, batteries will not work. Reason? When during low voltage, batteries won't work. Reason is both cancel each other. Understood or not? Right? Now tell me, do electrochemical cell can be made to behave as electrolytic cell or not? So that's why can I say every electrochemical cell can be electrolytic, but not every electrolytic cell can be electrochemical. Is it clear? So electrochemical cell reactions, can I reverse them or not? How I can reverse electrochemical cell reactions? By increasing E external. Clear? Are you able to understand? So I am writing that point. That is, if E external becomes greater than E of cell, then cell reactions can be reversed. Then cell reactions can be reversed. Correct? Right? If cell reactions get reversed, what happens to the size of zinc rod now? Observe here. What happens to size of zinc rod now? Zinc rod keep on increasing and copper rod keep on decreasing. When power gone, zinc rod decreases, copper rod increases. Are you able to understand? It keep on changing. Clear? Done, sir? Online. Do you have any questions in it?
No, sir.
Now, one more point, sir. In all these electrochemical cells, something is there in between. What is it? So we are going to discuss about salt bridge, right? So next point, salt bridge. Symbolically, we write salt bridge as double vertical line, right? Can I say salt bridge as U-shaped tube? Salt bridge is U-shaped tube or not? Just let me show that. And it is filled with some electrolyte, right? Or any salt dissolved in agar-agar solution. Condition. Why I am selecting agar-agar? It will not give any electrical conductance. Or if I take water, water also furnish some ions, no? It also creates some other conductance. So that's why I'm taking agar-agar, right? Which is extracted from seaweeds, right? Gel type material, which can behave as a solvent, but at the same time, it will not give any external ions. That's why I'm selecting agar-agar, right? In that, I will dissolve KCl or KNO3 or ammonium nitrate to make it a slurry. That slurry I will fill in that U-shaped tube. All these things are over. have not given a very good. I have not explained anything about solid bridge here last year. Okay, here I will show. Directly I will take that image. Shall I take this image? This is better now. So what is solid bridge? U-shaped tube. Stop talking. Right? Filled with slurry, or can I call it as paste of electrolyte in agar. Right? U-shaped tube filled with electrolyte in agar. So what is agar means? What is the role of agar? It can act as a solvent, but it should not furnish any new ions, right? It's a gel type material. Agar obtained from beads. See this? Is a jelly-like substance, consists of polysaccharides from the cell walls of some species of red algae. As found in nature, agar is a mixture of two components, linear polysaccharide agarose and heterogeneous mixture of smaller molecules like agaropectin. Right? Dana grass, okay, something. Where is about something about ions? Yesterday I don't wanna. Chemical composition. Alternating units of D-galactose and L-galactose heavily modified with acidified center of sulfate. Okay. See this property, what they are saying, melting point, hysteresis, something they have given, right? So it is having a good gel stability at relatively higher temperatures, right? So it will not get deformed or it will not get destroyed. So it behave like gel, so that that paste remains, or that paste kept inside will be folded, right? It will not convert into any liquid and it will not mix with other electrolytic solutions. Clear? So U-shaped tube filled with gel of electrolyte in agar. Nothing but paste of electrolyte in agar. What type of electrolyte I have to consider? Right? Mobility of cations and anions of that electrolyte should remain same. Right? This electrolyte have nearly same ionic mobility for cations and anions. For example, KCl aqueous, KNO3 aqueous, ammonium nitrate aqueous, etc. Such salts are mixed with agar-agar and made into a paste, and that gel was filled inside that U-shape. Why we have to consider them with same ionic mobility? Reason, when I dip this in, for example, this is salt bridge, right? This is salt bridge. Here I am taking zinc rod. And what is this electrolyte? Zn+2, correct? Zn+2 aqueous. Or zinc sulfate, ZnSO4 aqueous, correct, sir? During electron, and this is negatively charged. Now what happened during that functioning of the cell? Zinc rod comes into this solution as Zn+2, correct? What happens to total charge of this electrolyte now? What happens to total charge of this electrolyte? Becomes positive, correct? Because number of Zn+2 ions keep on increasing. As this electrolyte is becoming positive, it tries to pull anions from this electrolyte, which is present inside salt bridge, right? Anions are pulled towards Zn+2. Same way here, cations will be pulled towards electrolyte. If both ions are having same ionic mobility, what is the net voltage generated inside? 0. If they are not having nearly same ionic mobility, then a new voltage is created inside the U-shaped tube, right? If a new voltage got created here, can you measure actual voltage by using this voltmeter? You will not get actual voltage value. You will get some different value. Are you able to understand? Right? So such interfering electrode potential should not be created by electrolyte which is taken inside salt. Is it clear? Right? So that's why when we are discussing about salt bridge, that is the important condition. Electrolyte solution, these two tubes having diaphragm such as something nonsense does not here several type of salt bridges. There is the KCl type condition, man. See this, what they are saying, they should not create any, right? No junction potential should be created by the electrolyte which is taken inside the cell. See, traditionally the concentrated aqueous potassium chloride solution has been used for decades to neutralize the liquid junction potential. When comparing other salt solutions, right, KCl is most efficient in nullifying junction potential. Is it clear? Are you able to understand, sir? Any questions in this? So as such, they have given certain conditions, right? We can use filter papers also, but adding some by taking filter paper, dissolving KCl solution, we can use that filter paper also directly, right? So condition, no new potential generated electrolyte of salt bridge should not produce electrolyte of salt bridge should not create any potential, pressure, and should be inert. Should be inert towards electrolyte of cells. Why I'm saying it as they should be inert towards electrolyte of cells. We are immersing that salt bridge in ZnSO4 and copper sulfate, right? Whatever the electrolyte I am taking, that should not react with electrolyte present in anodic compartment and cathodic compartment. For example, here KCl is not suitable. For example, let me write that also. Note, KCl is not suitable in case of AgNO3 aqueous as electrolyte. For example, if I am taking silver rod, immersed in, I am taking silver rod, immersed in AgNO3 aqueous. In this case, I am using salt bridge. Here I should not use KCl here. I have to take KNO3. Reason? If I take KCl, what happens? This AgNO3 with Cl minus ions forms AgCl. Means electrolyte of salt bridge is interacting with electrolyte of cell. Right? That should be the condition. Right? So it should not create any new potential and should be inert towards electrolyte of cells. Clear, sir? Right? So they should not create any liquid junction potentials. Right? And major role of salt bridge is to close the circuit. Should close the circuit. Yes, sir. Yes, sir. Any questions, sir, about salt bridge? Clear? Huh? Now we are done with electrochemical cell part. Now we will see. Already you know about the standard hydrogen electrode, right? So we are now going to see different types of electrochemical cells, right? Listen, sir. Listen, please. This part is done or not? Right? Now I am going to see about different types of electrochemical cells, right? Before going to that, one important equation, that is Nernst equation. Already you know about Van Hoff equation. What is Van Hoff equation? Van Hoff equation, sir. Delta G equal to delta G naught plus RT ln Q, where Q is reaction coefficient, which is equal to concentration of products by concentration of reactants. And we already know Gibbs free energy delta G equal to delta G equal to minus NFE, correct? Huh? So if I substitute, what you will get? Minus NFE equal to minus NFE naught plus RT ln concentration of products upon concentration of reactants. Divide the total equation with minus NF. E equal to E naught minus RT upon NF log to the base E into concentration of products upon concentration of reactants. Response. We call this equation as Nernst equation. If temperature T equal to, if T equal to 298 Kelvin, and already you know F value, Faraday, what is that? 96,500 Coulomb. And instead of logarithm, log base C, can I write 2.303 into log base 10? So then what is left in the numerator? 2.303 into R into T divided by 96,500. If I substitute that value, this value becomes 0.0591. Then what will be the equation? E equal to E naught minus 0.0591 upon N log concentration of products upon concentration of reactants. Next heading, sir. Types of reference electrodes. Or I can write different electrochemical cells. Better I will write simply as types of reference electrodes. In which first type, sir? Electrolytic concentration cell. Electrolytic concentration cell. Observe this cell, sir. Zinc rod immersed in Zn+2 aqueous of concentration C1 molar, Zn+2 of concentration C2 molar, interface zinc. Now tell me how to write the reaction. What is the cell reaction? How to write this? This part is anode and this part is cathode. Now tell me what happens at anode. Always we know that at anode oxidation occurs. Tell me the oxidation reaction. What is the oxidation reaction? Zinc gives rise to form Zn+2 plus 2 electrons, right? Correct? Huh? What is Nernst equation for it? What is Nernst equation? E of Zn converted to Zn+2 equal to, see Nernst equation, E naught of Zn+2 to Zn, sorry, Zn to Zn+2 minus RT by 2F, right? Okay, NF, Ln concentration of product by reactant. Correct? So E naught of Zn to Zn plus 2 minus RT upon NF log to the base C, concentration of product by reactant is 1. Reason? Solid. Correct, sir? Any questions? No questions, na? Say something, ma'am. Let me write one more point also here. Let me write one more point. At equilibrium, what happens, sir? Every cell reaction, if that cell keep on happening, what happens to voltage of the total cell? Decreases. Finally, net voltage becomes 0. Means finally E becomes 0. Correct? Finally, net voltage of the cell keep on, concentration will keep on decreasing or not. For example, I am breaking zinc rod immersed in Zn plus 2. I am immersed zinc rod immersed in Zn plus 2. What happens to concentration of this? Keep on changing or not? Right? Here, Zn plus 2 converts into zinc. Here also concentration keep on changing or not? Correct? If they keep on changing, what happens to E value, EMF of the cell? Means slowly battery is getting discharged. After certain time, what happens to the net voltage obtained from the battery? Becomes 0. Means E becomes 0. E became 0 means what happens to delta G? E becomes 0 means what happens to delta G? 0. If delta G is 0, we call that process as equilibrium process. That's what I'm writing. At equilibrium. At equilibrium. Delta G becomes 0. Right? Means what is net voltage? E of cell becomes 0. If I substitute that value here, what will get? E naught equal to what, man? E became 0, then E naught equal to. Bring that term to this side. Correct? So what is E naught? Minus RT or plus RT now? Plus RT by RT upon NF ln concentration of product upon concentration of reactant. Now tell me, in any cell reaction, E may become 0, but E naught will never be. Correct, sir? Any questions in it? Right? E naught will never become 0. Only for hydrogen electrode it is 0. Right? Otherwise, always E naught value will be there, but E may become 0. Clear? E naught will never become 0. Respond. Here I am taking for cathode now. For cathode. What I will write for cathode? For cathode, shall I write reduction? What is reduction reaction? Zn plus 2 aqueous plus 2 electrons gives rise to zinc. Now, what about E? E of Zn plus 2 to Zn minus RT upon NF ln concentration of 1 upon concentration of Zn plus 2. Response, sir. Now I have connected both. As I have connected both, what is net cell reaction? What is net cell reaction? Zinc gets cancelled. 2 electrons gets cancelled. What is net cell reaction? Zn plus 2 aqueous gives rise to Zn plus 2 aqueous. Sir, why you are not cancelling these two? What is concentration of Zn plus 2 here? C1 molar. What is concentration of this here? Both concentrations are different, na? That's why I'm not cancelling. Are you able to understand? If these concentrations are also equal, if it is C1, this is also C1, then I will cancel that also. Then what is overall reaction? 0. Nothing is there. Are you able to understand? As their concentrations are different, I am writing this. Clear? Now, what is net E of cell? What is E of cell equal to? E of cell equal to E oxidation plus E reduction. Correct? E of cell equal to E oxidation part plus E reduction part. What is E oxidation part, sir? This plus this. Correct? So let me write that. Therefore, E of cell equal to E oxidation. Can I write E oxidation as E Zn to Zn plus 2 plus E of Zn plus 2 to Zn. Response, sir? Any questions in it? Now I am substituting the term. Therefore, E of cell equal to what is E of Zn to Zn plus 2? E naught of Zn plus 2 minus RT upon NF concentration of Zn plus 2 plus E naught of Zn plus 2 to Zn minus RT upon NF and concentration of 1 upon Zn plus 2. Response, sir? To avoid confusion, I am writing this as cathode and I am writing this as anode. No confusions now. Response, sir? What is the value of this? What is the value of this? Is it reduction or not? What is zinc reduction value? Minus 0.76 volts, correct? What is this value? Then what is net value? Right? Now observe this carefully. If I am adding oxidation, reduction, E values of same cell, they may not become 0. But if I am adding E naught values, E naught of this plus E naught of this, then what happens? 0. But sum of E values will not be 0. Are you able to understand? Sum of E naught values of same cell may become 0, but sum of E values will not be 0. Right? Now, what is the net equation? E of cell equal to, can I take minus RT upon NF common? What you will get? Concentration of Zn plus 2 at anode. What is concentration of Zn plus 2 at anode? C1. Concentration of Zn plus 2 at anode. So, then concentration of Zn plus 2 at anode upon. Response, sir. Will this be the equation or not? So now tell me, which is deciding the voltage of this cell? Concentration of electrolyte is deciding voltage of this cell or not? Voltage E of cell will be decided by C1 and C2 values or not? Correct? That's why this cell is called electrolytic concentration cell. So this cell value is decided by concentration of electrolytes. Any questions? Now, if C1 value is greater than C2, what happens? If C1 value is greater than C2, numerator is greater than denominator, what happens to this value? Total value E of cell becomes negative. Correct, sir? If C1 becomes greater than C2, E of cell becomes negative. That implies what is delta G? Delta G positive, then the process is non-spontaneous. If C1 is less than C2, C1 numerator is less than denominator, then what happens to logarithm term? Negative. Negative and minus of minus. Then what happens to E of cell? Positive. If E of cell is positive, delta G equal to minus NFE, then the process is means how to construct electrolytic cell. To construct electrolytic cell, what should be the condition? Concentration of electrolyte present in cathodic compartment. Correct, sir? C2. C2 must be greater than C1, na? So electrolyte of cathode must be greater than electrolyte of anode. Then only that cell exists. Otherwise, electrolytic concentration cells doesn't exist. Are you able to understand? Any questions in it? Right? Do you have any questions in this? No, no? Right. Now I am taking one more, sir. Another same cell I am designing. Note. Platinum, H2, gas, 1 atmosphere, interface, H plus, aqueous, C1 molar, salt bridge, H plus, aqueous, C2 molar, interface, H2, gas, 1 atmosphere, platinum. Now, sir. Now tell me, what is this? Anodic compartment, cathodic compartment, oxidation occur, reduction occur. Now tell me, what is the final E of cell equation? Sorry, sir. What is anodic reaction, sir? Okay, let me write anodic reaction. Tell me anodic reaction. H2 gas gives rise to 2H plus aqueous plus 2 electrons. Right? Now, what about E? E of H2 to H plus equal to next equation. E naught of H2 to H plus minus RT upon NF, of course, 2F logarithm concentration of H plus square upon P of H2. Yes, no? Response, sir. For hydrogen electrode, we wrote that. Say something. No. For cathode. Every time I will not write this one, man. Right? This and this you have to add directly. You have to give the final E of cell equation. You should not write every time this part. Okay, as of now, you let me do this. But later on, I will skip these steps. I want direct final equation. Okay. What is this equation now? Here. Better I will write here C1 molar so that you will not get confused. Huh? Here 2H plus aqueous C2 molar plus 2 electrons gives rise to H2 gas. This is also 1 atmosphere, correct? Huh? This is also 1 atmosphere. E of H plus 2 H2 equal to E naught of H plus 2 H2 minus RT upon NF ln P of H2 upon H plus square. Right? Now what is overall? Therefore, E of cell equal to What is this value? 0. This value. If they are not 0 also, what happens to E naught of cell? 0. Because at anode and cathode I am using same electrolyte and same electrode. As both are same, even though if they are E naughts are not 0, the moment I add them, automatically it becomes 0. Clear? Huh? Response, sir. So I am not taking this. Directly I am writing the equation. Minus RT upon NF ln. Instead of H plus, can I write C1 square? Response, sir. C1 square upon C2 square. Where C1 square upon 1 into 1 upon C2 square. Correct? Say something, sir. If I want to make this cell to exist, what should be the condition? C2 must be greater than C1. Right? Then only, if C2 greater than C1, then only C2 greater than C1, then this total E of cell becomes positive and delta G of cell negative. Then only such a cell exists. Otherwise, such a cell doesn't exist. Right? Response, sir. Any questions in it? Right? Now, same cell I am modifying. Observe carefully. Platinum, H2, gas, P1 atmosphere, interface, H plus, aqueous, C molar, salt bridge, H plus, aqueous, C molar, interface, H2, gas, P2 atmosphere, platinum. Now, sir, what is E of cell? I don't want remaining all nonsense. E of cell equal to minus RT upon NF ln P2 by P1. Very good. P2 by P1. Condition. P1 must be greater than, better I will write here. P1 greater than P2. Now tell me, here I am changing concentration of electrolyte or electrode. Electrode I am changing, not electrolyte. Electrolyte concentration is same. That's why what we call this cell as. This is electrolytic concentration cell. Now this is electrode concentration cell. Are you able to understand, sir? Respond. Online. Anyone alive? Online, respond.
Yes, sir.
Yes, sir.
Are you following or not?
Yes, sir.
So again, I am repeating. If it is electrolytic concentration cell, which should be more? Concentration of see, concentration of among C1, C2, which must be I man. Right? C2 means concentration of cathode must be greater than anode. If it is electrolytic cell, concentration of cathode must be greater than anode. Then only cell will function. If it is electrode concentration cell, concentration of anode must be, anode, this part. Anode must be greater than cathode. Then only cell will function. Is it clear? Any questions in it? I am taking note. Alright, instead of saying, can I write this cell in this way also? Check. I am writing this cell in this way. What is the difference between above and this? Why I removed solid bridge? Why I removed solid bridge, sir? If both concentrations are same, if both concentrations are same and both are same electrolytes, why we need to take them separately in two different vessels? Are you able to understand? We can take them in a single vessel. Both electrodes can be immersed into the same vessel, na? That's what I have done. Clear? In this case, no need of solid bridge, no. Because both our electrodes are kept into same electrolytic solution because concentration of that electrolyte remains same. Understood? Now I am taking a note. Same thing I am taking, but I am changing the concentration of both electrode and electrolyte, both, sir. I am changing the concentration of electrode and electrolyte both. Tell me the final equation. I don't want remaining all stuff. C1 molar, C2 molar. Now, what is E of cell equation? Minus RT by NF log to the base E C1 square, and this will be product side now. This will be reactant, this will be product, right? C1 square into P2, correct. C1 square into P2 upon C2 square into P1. Any questions? So we are done with electrode concentration cell, electrolytic concentration cell. Clear? Response, sir. Means, can I say why I call this as a reference electrode, sir? Because same electrode, can I use it as cathode as well as anode? I am using it as cathode as well as I am using it as anode also, no? Right? Clear? So better instead of using this word reference, let me call it as types of electrodes. Now I am taking third type, sir. Before going to third type, I will forget one more idea. If I don't teach now, it will get skipped. So let me take it as very, very, very important point. It is also as a note. Latimer diagram. Latimer diagrams. Otherwise, I will forget. Latimer diagram means if same metal can exist in different oxidation states. If I write all of them in one order, then we call that as Latimer diagram. Just I will show one example, then I will come back. Are you able to answer? Here manganese is in +7 state, +6 state, +4 state, +3 state, +2 state, 0 state, right? So to convert +7 to +6, +6 to +5, +5 to +3, +3 to +2, for every conversion, voltage is required. No? If I write all of them in one order, we call the diagram as Latimer diagram. Observe this case also. chromium +6 to +5, +5 to +4, +4 to +3, +3 to +2, +2 to 0. Right? So writing different oxidation states of a particular metal in one order, we call that as Latimer diagram. Any questions? Right? So I will take one example. I am taking this example. No need to write that in words now. Will you understand now? Right? So Latimer diagram means writing better here. Let me write. What is the oxidation state of manganese here? +7. Here it is +6, +4, +3, +2, 0. Right? This representation is called Latimer diagram. Now observe this Latimer diagram carefully. This is a 0.95. Okay. This is 0.56. They're all not commas here. 1.51, 1.18. Now, if E value is positive, delta G value negative. Correct? Delta G negative means process is spontaneous. Correct? Now observe this case, sir. Take this one. MnO4 2- converted to MnO2. What is E? 2.26 volts. Correct? What is N? How many electrons? +6 converted to +4. So N is 2. Then what is delta G? Minus N F E. Correct? Sponsor. Now I am writing one more reaction. MnO4 2- converted to MnO4-. Observe carefully. What is E? MnO4 2- converted to MnO4-. What is E? Minus 0.56. What I have done? I reversed it. +7 to +6 is reduction, na? But what I am writing here? Oxidation, na? So I reversed it. So what is E? Minus 0.56. What is N? 1. What is delta G? Minus 1 F minus 0.56. Correct, sir? Response, sir? Yes. Now I am reacting, adding both, sir. Now what I got? 2 MnO4 2- gives rise to MnO2 plus MnO4-. Correct? Respond. What is this first step? Oxidation or reduction? Here +7. +7 or +6? +6 converted to +4. Here +6 converted to +7. What is this one? +7, 6 to +4 means reduction. Second one is correct, sir? Now I am adding both. Then what is this reaction? Redox, na? In any redox reaction, number of electrons gained and lost must be. How can I make them equal? How many electrons in first? 2 gain. But in second? Means I need to multiply this with? 2. I am multiplying with 2. If I multiply with 2, what is N now? Then this becomes. You should get some doubt. You got any doubt? Number of electrons change, but E0 values will not change. E0 is standard, right? E0 values will never change. E values may change. If I multiply them with some number, E values may change, but not E0. All these are standard EMF values, right? Is it clear? So can I write this as 3, this as a 2, and this as the 1, correct? Now what is delta G equal? Is equal to minus 4.52 F, correct? This one plus 1.12, 0.56 into 2, man. 1.12 F. What is net delta G value? Negative. Means what is that? Minus 2.3. If delta G is negative, process is, means can I say MnO4 2 minus can undergo disproportionation reaction? Response, sir. Correct? Now, instead of writing this everywhere, if voltage towards right side is more than voltage towards left side, such ion can undergo disproportionation. Are you able to understand? Now, what about this? Do MnO2 can undergo disproportionation or not? No. Reason? Right side value is not greater than. What about Mn plus 3? Yes. Mn plus 2. No, or it is negative. Are you able to understand? So in Latimer diagram, if EMF value or E0 value towards right side is greater than left, then such a species can undergo disproportionation. Hence proved. Are you able to understand? Now I am deleting this. So I am deleting this. Directly I am writing that statement. If EMF towards right of a species is greater than its left, then such a species towards its left in Latimer diagram. Then what happened? Then such a species can undergo disproportionation. So that's why I'm underlining MnO4 2 minus, Mn plus 3. That's all. So these two will undergo disproportionation. Any questions in it? Response, sir. I am taking one more. Simple thing, I will take iron. With iron, I will show. Of Fe. I am taking this one, sir. Now tell me, do Fe plus 2 can undergo disproportionation or not? No. Reason? Towards right side is not greater than left side. Now I am taking this as another example, sir. Another example. Observe this image carefully. Please. They gave this Latimer diagram. Listen, sir. Stop talking. They gave this Latimer diagram and they have not given this value. This value is not known to us. We need to find it. How to find? They gave this Latimer diagram and they have not given this value. Fe plus 3 to Fe value was not given. I need to find it. How to find it? How to find it? Observe this. This I am writing in a general format. M plus N3. I will do one thing. M plus A converted to M plus B converted to M. M plus A directly converted to M. Right? Or I will write plus N3. Now tell me, from M plus N3 to M, what is change in number of electrons? N3 electrons. Let it have some EMF value as E3 naught. Right? Now. Now let me assume this as N1. From here to here, how many electron transferred? Let me consider its EMF as E1 naught. Now here, let me consider number of electron transferred is N2, EMF as E2 naught. Now what is N2? N3 minus N1 equal to N2. Can I write? Response, sir. Correct. Now I am writing those three reactions separate. Can I write those reactions in this way? M plus N3 gain N2 electrons to form M plus N1. Can I write it? Response, sir. Any questions in it? Now what is delta G here? I'm writing delta G1 naught equal to minus N2F E2 naught. Say something. Yes or no? No. M plus N1 plus N1 electrons gives rise to M. What is delta G2 naught? N1 F E1 naught. I am adding both. Now tell me, do N1 plus N2 is N3 or not? No. I am adding both, sir. Can I cancel this and this? Then M plus N3 plus how many electrons? N1 plus N2 electrons is nothing but equal to M. Now what is delta G3 naught? Minus N3F E3 naught. Correct? Response, sir. Now from here can I write? From here can I write? Oh, sorry. Therefore, delta G3 is equal to delta G1 plus delta G2. Can I write? Right. Energies can be added or not? Right. Gibbs free energy is an delta G is extensive property or not? As this is extensive property, I can add it or not? Right? Response, sir. Now, what is this delta G3 naught? Can write minus N3 F E3. So minus N3 F E3 naught is equal to minus N1 F E1 naught minus N2 F E2 naught. Can I take minus here common and cancel? So what you got? E3 naught equal to N1 E1 naught plus N2 E2 naught upon N3. Respond. This is like P final equal to P1 V1 plus P2 V2 upon V final. Pressure is an intensive property. Correct? Now tell me, what is EMF? What is EMF? EMF is intensive. As EMF is intensive, EMF values are not additive. That's why don't write E3 equal to E1 plus E2. Are you able to understand? If its EMF is, that's what I'm saying here. Its EMF is 0.77. Its EMF is minus 0.44. What is the total EMF plus from FE plus 3 to FE means? Don't blindly add this value and don't say this value. Are you able to understand? If you want this value, what I have to do? I need to find it. So let me consider this as E3. What is number of electrons now? N3 equal to 3. Here, let it be considered as E2. And what is N2? 2. Let this be E1. What is N1? 1. So what I told you? E3 equal to N1 E1 plus N2 E2. Correct, sir? Upon N3. Response, sir. N1 E1 plus N2 E2 upon. So what is this value? 0.77 minus 0.88 divided by 3. So what is that value? Minus 0.11 by 3. So 0.033s are 9. Means how many? 2. 2 means 6 are 18. Again 2 0. Again 6 are 18 and so on. So what is that value? Therefore, E3 value must be equal to minus 0.03. Can I write as 7? Are you able to understand how we got that value? Is it clear? Right? Respond, sir. Any questions in this? So, I'm deleting all this nonsense. Not necessary, na? You want this or not? Then let me take this. Right? So, EMF of a cell is intensive property. Therefore, it is not additive in nature. Gibbs free energy is extensive. It is additive in nature. So, if you want to add any two cell reactions, convert them into Gibbs free energy and add. Don't directly add the EMF factors. Clear? Now, observe another condition. If number of electrons gained and lost are equal, if N1 value, N2 value, N3 values are equal, then if N1, N2, N3, all the three values are equal, then add directly. Then can I write, this is the reason why I am writing E of cell equal to E oxidation plus E reduction. Here always I am writing E of cell equal to E oxidation plus E reduction I am writing na. Reason, redox reactions. In redox reactions, number of electrons gained and lost will be equal. Means N1, N2, N3, all the values become equal. As they are equal, directly I am writing E of cell equal to E oxidation plus E reduction. If they are not equal, I should not write E of cell equal to, right? I should not add both. Clear? I have to write as N1 E1 plus N2 E2 upon N3. Understood? Right? Now I am going for third one. What we are discussing about? Okay. Third type, sir. Metal ion electrode. Metal ion electrode. Actually, we have completed electrochemical cell part. We are done with electrochemical cell part. So 3 parts are over, only 2 parts left. What are they? Batteries, corrosion. Right? Before going to these two, we are solving numericals in a general format. And instead of solving problems, I am taking different conditions of problems. I am writing the equations. Right? Already 2 conditions we have seen. No, not 2 conditions. 3 conditions we have seen. What are they? If I change concentration of electrolyte, if I change concentration of electrode, or if both are changed, or if Latimer diagrams are given. Are you able to understand? So we are seeing different formats. So now I am going for metal. But before going to that, let me show you that 1 or 2 questions. Then I will come back so that there will be clarity over it. I will do one thing. Let me open that star mark questions. Class 12, electrochemistry, please listen. Array, yeah. Stop talking and listen, man. Right? I am opening electrochemistry ebook. In this, do this part is over or not? Have we solved all these questions? Kohlrausch law done? Applications of Kohlrausch law? Hey. C alpha square by 1 minus alpha. Right? Conductometric titrations. Electrolytic cell. Electrolysis of NaCl using inert electrodes. Using mercury. Dilute NaCl. Electrolysis of copper sulfate. Using copper as anode. Acidified H2SO4. 50% sulfuric acid. Preparation of hydrogen peroxide, man. Faraday's first law. Faraday's second law. Done or not? Now we will see this exercise. I will do one thing. First, I will copy this part. Solve, sir. Question number 6. Solve that question number 6. Conductivity of water is given. Lambda naught of H plus given. Lambda naught of OH1 is given. What is degree of dissociation of water? Lambda is given. Lambda naught of H plus, lambda naught of OH1 is given. If I add these 2 lambda naughts, what I will get? Lambda naught of H2O. What they want? Alpha. Degree of dissociation, man. Degree of dissociation means alpha only, no? So what is alpha? Lambda upon lambda naught. What is lambda? 0.55 into 10 power minus 7. I feel like I solved this. No? Upon 350 plus 200. Upon 550, yeah. Let's say something, man. What is this value? Into 100, They want degree or percentage? Degree only. So no need to multiply with 100. If they ask percentage, I will multiply with 100. So what is this value? How many times? 55 tens, 55 10 power minus 2s. So divided by 10 means 10 power minus 3. Minus 3 into 10 power minus 7. So what do you got? Something wrong. There is something wrong, man. We are not getting 1.88. 1.82. We are not getting 1.82. Wait. Array, listen. This is not lambda value. See the unit. They gave kappa, right? And they want alpha. Degree of dissociation means alpha. First, I need to find lambda. So what is lambda equal to? Kappa into 1000 by molarity, right? Say something. What is kappa value given? 0.55 into 10 power minus 7 into 1000 by what is molarity of water? Weight by molecular weight, number of moles. Na? Here what I have to write? Number of moles only. Na? If I take 1000 ml, means 1000 grams, how many moles? 1000 by 18. So 1000 by 18, that becomes into 18. Let's say something. 1000 gone. So what you got? 0.55 into 10 power minus 7 into 18. Therefore, what is alpha? 0.55 into 10 power minus 7 into 18 upon 550. Correct, sir? So what is that value? 18 into 10 power minus 10. Means answer must be 1.8 into 10 power minus 9. So answer must be. What is 6 man? This we will write as 55 into 10 power minus 2. This has 55 into 10 times. So 10 power minus 2, 10 in denominator goes to numerator 10 power minus 3, 10 power minus 3, 10 power minus 7, 10 power minus 10. So 18 into 10 power minus 10. So we can write as 1.8 into 10 power minus 9. Response, sir. Why they got 1.82? Because they wrote this value as, instead of 1000 by 18, they wrote as 55.56. Correct? If I write that, you will get the value as some more fraction. Clear? Say something. Next question, sir. Which of the following does not involve oxygen at anode when an electrolysis is carried out? If it is fused NaOH, what are cations? Na plus anions. Now OH minus at anode gives 2 electrons plus H2O plus half O2. Correct? So at anode you are getting oxygen or not? So option 2 is ruled out. Next, sir. What about acidic water? Acidic water. Acidic water means H plus H2O. Correct? Acidified water means cathode is at cations are H plus. Acidified water means in water I am adding acid, man. Right? So H plus is present. At anode, H2O is present. Acidified water, that's all. H3O plus, that's all. Correct? Now here, dilute sulfuric acid. What happened? H plus, HSO4 minus and H2O. Dilute, na? If it is concentrated H2SO4, means 50% H2SO4, then what I will write? I will not write water. Or if it is 50% H2SO4, what I will do? At anode, HSO4 minus undergoes oxidation to form H2S2O8, preparation of hydrogen peroxide. Correct or not? Now, dilute H2SO4 with copper electrode. What happened? With copper electrode and here with platinum electrode. What is the difference? with copper electrode and with platinum electrode. What happened? Say something. A copper electrode is active electrode. Platinum electrode is inert electrode. Is it, as it is inert electrode, it doesn't interfere. If it is copper electrode, it can react. Correct or not? Means SO4 2- will make copper at anode. At anode, what should happen? SO4 2- ions or HSO4- ions react with copper +2 to form CuSO4. How I got copper +2? At anode, if copper converts into copper +2, then only this reaction will happen. Are you able to understand? Right? So copper can act as active electrode. As this is acting as active electrode, it will interfere in the reaction. As it is interfering in the reaction, copper can undergo oxidation. Are you able to understand? Any questions in it? Right? Clear? I am taking dilute sulfuric acid copper, man. The moment I immerse copper in dilute sulfuric acid, copper sulfate will be formed or not? H2SO4 with copper fused, CuSO4. Now, then what happens to electrolyte now? Electrolyte becomes copper sulfate. If a copper sulfate is electrolyte and copper is anode, what happened? Again, I am repeating, sir. Again, I am repeating. Listen. I am talking about option number 4. I am talking about option number 4. The moment I mix copper and dilute sulfuric acid, right? I am not talking about electrolysis reaction. Chemical reaction I am talking about. These two will convert into CeSO4 aqueous plus H2 gas. That H2 gas is gone. What is left now? So CuSO4 aqueous is the electrolyte. Correct? What is anode? Copper anode. Which is cathode? Copper cathode. Correct? Means when metal is used as anode, in its metal ion solution, what happens? Anode undergoes oxidation. If anode undergoes oxidation, what happens? Copper converts into copper +2 at anode, no? So oxygen will not be liberated. Are you able to understand? Clear? Any questions? So answer must be 4th option. Reason: copper is active electrode, not inert electrode. Active electrode. Understood, sir? Next one, sir. In electrolysis of alkaline water, a total of 1 mole gases is evolved. The amount of water decomposed is alkaline water, man. Means OH- is present in water. Right? Now, what happens at cathode? And what happens at anode? Alkaline water. I am taking barium hydroxide aqueous. We discussed this in hydrogen's compound chapter, fuel cells. So we discussed this point, man, in hydrogen and its compound chapter under the side heading fuel cells. We discussed this. At the cathode, hydrogen gas is pumped. At anode, O2 is pumped. And this is done in a alkaline solution. Example, best alkaline solution is barium hydroxide. Reason: atmospheric carbon dioxide will react with barium hydroxide to form barium carbonate, which is insoluble. If it is insoluble, it will not form any scaling on the surface of rod, so that cell reaction becomes efficient. I should not take sodium hydroxide. Reason: with atmospheric carbon dioxide forms sodium bicarbonate or sodium carbonate. They will form one layer on the surface of electrodes. Because of scaling, efficiency decreases. Best example, while you are heating water by using electrical heaters, After a few days, you will see white color coating on the surface of heaters. We call that as scaling. Discussed or not? Huh? Right. So I am taking barium hydroxide. What are the anions present? So 2OH minus gives 2 electrons plus H2O plus half O2. Reaction got balanced or not? Now at cathode, can I write H plus or I have to write H2O now? At cathode, I should not write H plus. Reason? What is solution? Alkaline water. I should not write H plus because free OH minus ions, generally enthalpy of formation of H plus is 0. That freely obtained H plus ions react with OH minus to form H2O only now. So I will not write H plus here. So H2O gives rise to form plus 2 electrons. Gives rise to form. What I have to do? What I have to do? Say something. What I have to do now? See this. 2H2O plus 2 electrons gives rise to 2OH minus plus H2. Check the reaction. Balanced or not? Balanced or? What is overall reaction? What is the overall reaction? H2O gives rise to H2 plus half O2, correct? How many electrons are used for total reaction? Hey, 2 electrons gain, 2 electrons lost. Means the total how many electrons involved? By passing 2 Faraday electrons, totally 3/2 moles of gases liberated. Here 1 mole, here half mole. Totally 3/2 moles of gases liberated by using 2 Faraday. Correct? Now what they are asking? Total of 1 mole of gases is liberated. Only 1 mole of gas is liberated. Then amount of water decomposed is. If 1 mole of water decomposed, how many gases obtained? For 1 mole water, 3/2 moles of gases liberated. If it is 1, how much it is? X. So what is the answer? Understood or not? Any questions in it? Response, sir. Next question. Question number 9 and 10. See this question number 9. Alright, you will not get confused now between this. Better I will write that also. 1 minute. For this question number 8, let me write that reaction. At cathode, what I will write? H2O, 2 moles plus 2 electrons to form 2 OH minus plus H2O. And at anode, 2 OH minus gives rise to 2 electrons plus H2O plus half O2. Correct, sir? Overall reaction. H2O gives rise to H2 plus half O2. Correct? So 1 mole H2O gives 3/2 mole gases. So to have 1 mole gas, X mole H2O is used. So from there we are finding X. Correct, sir? 1 upon X equal to 3 by 2. That implies X equal to 2 by 3. We solved it. Now come to question number 9, sir. How many coulombs of electricity will be consumed when 100 milliampere current is passed through a solution of silver nitrate for half an hour during electrolysis? Faraday's first law. Correct? Hey, not even first law, man. What they want? How many coulombs of electricity is consumed? Means Q. They gave I and they gave T. So what is formula? Q equal to I into T. Correct? So I value 100 into 10 power minus 3 ampere time 30 into 60. So 6 3s are 18 into 10. 180, yeah? Response, sir. Are 2 zeros and 1 0. 10 cube gone. So 60 into 3. So answer must be 180 coulomb. Response, sir. Next question, sir. What they are asking? 1 coulomb of charge is passed through a solution of silver nitrate, copper sulfate, which are connected in. Then what is it? Faraday's second law. And the concentration of two solutions are in the ratio 1:2. What is the ratio of weight of silver and copper deposited on platinum? Who cares about their concentration ratio? What I told you in Faraday's first law, second law, charge passed through first cell is always equal to charge passed through second cell. It doesn't depend upon what is the concentration of them. Na? It depends upon only Q. So weight of silver by equivalent weight of silver equal to weight of copper by equivalent weight of copper. Correct or not? So they want weight ratios. What I have to do? I am writing. Charge passed through both the cells must be equal. If I pass 2 Faraday through copper, amount of charge passed through silver will be 2 Faraday, right? So Q passed through Ag and O3 must be equal to Q passed through CSO4. That is, on passing 2 Faraday, on passing 2 Faraday, what happened? The amount of current passed through silver nitrate, if it is 2 Faraday, here also it should be 2 Faraday. If I pass 2 Faraday, how many moles of silver will deposit? 2. Because 1 Ag is Ag plus. If I pass 2 Faraday, 2 Ags will be deposited here. 1 Cu plus 2 will be deposited. Right. Here copper is in. Here copper is in plus 2, man. Here silver is in Ag plus. I am passing 2 Faraday in both. Then amount of silver deposited will be 2 Ag. Amount of copper deposited will be 1 C. Correct? Respond. So on passing 2 Faraday, weight of silver deposited equal to 2 into 108. Correct? Then what is weight of copper deposited? 63.54 grams. Response, sir. So what is the ratio? They gave 107.9. Okay, let me write that. Instead of writing 108, I will write as 107.9 gram. Then what is the value? 2 into 107.9 is to 63.54. 107.9 is to 31.77. Correct. Now come back to this. Now, electrochemical cell, over or not? Done? Next. What is the function of salt bridge? To connect both, to complete the circuit, to keep the solutions electrically neutral. It should not create any liquid junction potential, correct? To prevent mechanical mixing of both solutions, and electrolyte present in salt bridge should not react with electrolyte of cell, right? Now working of cell already done. Electrode EMF of a cell done or not? Standard electrode potential, standard hydrogen electrode, electrochemical series, applications, discharge potentials, Nernst equation, equilibrium constant and cell potential. Right, equilibrium constant, what is cell potential? E value. But E naught will not be. What is E naught? From this equation, what is E naught at equilibrium? 0.059 by n into log K equilibrium. Right, here now Q becomes K equilibrium at equilibrium. Right, at equilibrium, better I will write that part also. At equilibrium, Q becomes equal to K equilibrium. Respond. Next. Concentration cell over electrode concentration cell, electrolyte concentration cell, oxidation potential, reduction potential are a same graph, same equation. They are plotting graph, nothing. What is this part? What is this part? What is slope? Sorry, what is intercept? E naught is the intercept, na? Correct. What is slope? 2.303 RT by NF will be slope. Okay, remind me this tomorrow, right? So in next class, remind me about the graph. We'll plot the graphs and then we'll go. Next one, sir. Various types of electrodes. That's what we are going to see. Metal ion electrode. Just now I started. Correct? So these are types of electrolytic cells we will see. Then we will go to exercise. Then batteries. And after that batteries, corrosion. That ends the chapter. Clear? So next class, remind me from where I have to start. Graph. Right? After discussing that graph, we will go to types of cells, then batteries, corrosion, and we'll start solving numbers. Okay, wow. Online. Are you getting clarity over this chapter or not?
Yes, sir.
Yes, sir.
Remember,
Yes, sir.
electrochemistry, I am repeating again, electrochemistry is very, very important chapter, sir. We should not miss any point in this chapter, right? In class 12th, we have only 3 chapters in physical chemistry, sir. Remaining chapters are deleted, right? What are they? Solutions and colligative properties, electrochemistry, chemical kinetics, and nuclear chemistry. That's all. These 3 chapters only. Solid state deleted, surface chemistry deleted. But remember, class 12th physical chemistry weightage is, or if they want to give full length paper only from class 12, they have to give 33.33 questions from, percentage questions from physical. Same 33.33 for inorganic, 33.33 for organic. Clear? That's why they will give more number of questions from physical chemistry part of class 12. Clear? So be thorough with these chapters, right? Okay, sir. I will end the session. Online students, you can leave, sir. Right? I will give you your attendance. I will download from online and I will do.